Okay, one last part. You guys are doing amazing. Good job sticking with it. I promise this won't be that too long. So before we were working with numbers that were less than 1, but 6 halves is more than 1. But this isn't super friendly to work with. So no need to write this down, but I drew us a number line. Remember, this is saying I have 6 parts and the whole is 2. So here's my number line. Look, I have 0 to 1, 1 to 2, 2 to 3. Right now, let's just look 0 to 1. That's what we've been drawing before. If I'm working with halves, means I need 2 parts to it. 2 parts, 1 line. I'm going to put it right there. So if I were to number this with halves, I'd have 0 halves, 1 half, 2 halves. And remember, we've talked before, 2 halves is the same thing as 1. It's saying you have 2 out of the 2 parts. So what I want us to do with the 6 halves is pull out the whole numbers. Here's what I mean by that. We are going to write a series of addition numbers, adding different numbers together, that will equal 6 halves. But I'm going to pull out the wholes. So 6 halves, I have at least 2 halves. I need to keep pulling out as many 2 halves as there are possible. So what if I added another 2 halves here? What is 2 halves plus 2 halves? Is that 6 halves? No. 2 halves plus 2 halves would be 4 halves. So let me try adding another one here. 2 halves. Now what do I have? 2 halves plus 2 halves plus 2 halves. 2 plus 2 plus 2. Is that 6? It is. Remember, the bottom number stays the same. So 6 halves is like having 1 whole, 2 wholes, 3 wholes. 2 halves plus 2 halves plus 2 halves is 3. So 6 halves is the same thing as 3. 3 is so much easier to work with. That's why whenever possible, we always turn, these are called improper fractions. We always turn improper fractions into whole numbers or mixed numbers if possible. 6 halves is a little confusing for our brains to think about. 3 is much easier. Let's do that again, because I'm sure you're like, what? So this time we have 8/5. This time we're working with fifths. So if I had 0 and 1, I want 5 parts. I'm going to use 4 lines. 1, 2, 3, 4. There we go. So 0 fifths, 1 fifth, 2 fifths, 3 fifths, 4 fifths, 5 fifths is the same thing as 1 whole in this problem. So let's pull out a 5 fifths, pulling out the whole. Let me keep going. Could I pull out another 5 fifths without going over? Could I have 5 fifths plus 5 fifths? What would that be? 5 fifths plus 5 fifths, that would be 10 fifths. Too much. So what number here, 5 fifths plus what would equal 8 fifths? 5 plus 3 equals 8. So our bottom number, remember, stays 5. So this number is improper. The number on top is larger. We could make this easier to work with by saying we have 1 whole plus 3 fifths. So we'd be right here. 3/5, so 1 whole, 5 over 5 is 1. Same thing as 1, plus 3/5. Look at how I'm going to write this. That is the same as having 1 whole and 3/5. 1 whole plus 3/5. 8/5 is the same thing as 1 and 3/5. Let's do that one more time together, and then we'll do a little bit of practice. So this time, if we're working with 7/3, the number, the whole that we're working is thirds. How many thirds do I need to equal 1? 1. This one was 5/5. Now we're working with thirds. We would need 3/3. So I've pulled out the 3/3. I need to see, could I pull out another 3/3 without going over? What would 3/3 plus 3/3 be? 3 plus 3 would be 6. I have at least 6. So let's pull out another 3/3. I'm not quite there yet because I know 3/3 plus 3/3 isn't 7/3. Can I pull out another 3/3? If I had 3 plus 3, that'd be 6, plus another 3, that would be 9. Too much. So what should go here? 3 plus 3 plus what equals 7? 3 plus 3 plus 1 would equal 7. How many wholes do I have here? This equals 1. This equals 1. This is still just 1/3. 1 plus 1 is 2 and 1/3. 7/3 is the same thing as 2 and 1/3. So here's the problems on the problem set we're going to use to practice. It's question 3. And I'm taking away the number line part again just because there's not enough room. So number 3 on the problem set, it's on page 12, says express each of the following as a sum of the whole number and a fraction. So at the end, they want to look like this. That is a mixed number. One of these. Okay, I will get you started. On A, what are we working with? What is our whole? Bottom number? We're working with sevenths. How many sevenths do you need to have the whole thing? 7 sevenths. That's equal to 1. Could you pull out another 7 sevenths without going over 9? No, you couldn't. So how many more sevenths do you need to equal 9? 7 plus what equals 9? 2. 7 sevenths plus 2 sevenths equals 9 sevenths. So what would this be as a mixed number? I know 7 sevenths is 1. 2 sevenths, I can't write any other way. So this would be 1 and 2 sevenths. Use this as a guide to help you solve. I would like you to do B and let's do C. B and C. Okay, pause the video. Remember, you're pulling out as many as you can. This one, it only happened to have 7 sevenths I could pull out. This one, you're working with halves. How many halves can you pull out? And this one, you're back to using your 7 sevenths. Pull out as many as you can. Okay, pause, and then let's check. Okay. Okay, this is your last part. You're doing great. So in this one, 1 whole would be equal to 2 halves. So I could pull out 2 halves. If I pulled out another 2 halves, I haven't gone over. I have 2 halves plus 2 halves, that'd be 4. Can I pull out another one? Another 2 would be 6. Can I pull out another one? Yeah, that would be 8. 8 halves. So I have 2, 4, 6, 8 halves, but I need to equal 9 halves. So I need to add 1 more half. So if this is 1, this is equal to 1, this is equal to 1, this is equal to 1, this stays a half. What do we have? 1, 2, 3, 4 and a half. 9 halves is the same thing as 4 and a half. This one over here, I can pull out 7 sevenths. I can pull out another one because that would be 14 sevenths. And I can pull out another one. That would be 21 sevenths. But I need 22. So I have 21 sevenths plus 1 seventh is 22 sevenths. 7 sevenths is equal to 1. 7 sevenths is equal to 1. 7 sevenths is equal to 1. And then we have our 1 seventh. So total we have 1, 2, 3, and 1 seventh. All right, that is it for today. You guys did such a good job. There is an exit ticket. I had to change it a little bit because it's just really hard to get you to do a number line on the computer. So for this one, you're going to solve. You are not going to be showing the expression on a number line, but you could use that to help you solve. So 5/5 plus 2/5, what would that be? And then 6/3 plus 2/3, what would that be? And then down below, I am going to have you do kind of a changed version of this. So for 6/9, I'm going to have you solve kind of like we did on question 2. How could you break up 6/9 into fractional parts? And it'll probably be like a fill in the blank. Like what would these numbers be? Okay. And I think we're just going to skip B. We'll just do it once. Okay. Good job. This was a lot today, but you did great. Thank you so much for getting to the end. Bye.